So here is the next question. It says, find what is a buoyant force on a boat whose volume that has a volume of 250 cubic meters submerged beneath the water. So go ahead and pause, try to solve this one, and when you're ready, unpause. Alright, so let's try to do this. There's only one number, 250 cubic meters, so that's a volume. And let's see what's happening. So this is water. You have a boat, and part of the boat is underneath the water. So this is the part of the boat underneath the water, and that's the volume submerged. And the part of the boat that's submerged on the water, that's the buoyant force is gonna be. That's what the buoyant force is gonna be defined by. So the buoyant force is gonna be defined in terms of this volume here, and that's what we want to find is a buoyant force. And so the equation for the buoyant force is just density of water multiplied by the volume submerged times g. So this is just a plug-in. So the buoyant force is going to be density of water, which is a constant, which is going to be 1,000. The volume submerged is 250, and times g, which is 9.81. And so the buoyant force is going to come out to be 2.45 times 10 to the 6 newtons. Alright, so now try this one. This says a hydraulic pump has one end with a cross-sectional area of 0.2 square meters and the other end with a cross-sectional area of 0.85 square meters. If 12 newtons is applied on the small end, what is a force on the large end? And part B, if water flows through the large end at 0.36 meters per second, what is a flow rate through that end? Okay, so go ahead and pause, try to solve this one, and when you're ready, unpause. Alright, so let's try to get the answer. First number is a 0.2 square meters, so that's an area. Next number is a 0.85 square meters, so that's another area. You have a 12 newtons, that's a force. And 0.36 meters per second, so that's a velocity. And for A, we want to find another force. And for B, we want to find the flow rate Q. So let's draw a picture to see what's happening. So this says hydraulic, so this means that this is basically Pascal's principle, which I'm going to simplify to this example here. You have a pipe with a small end and a large end, and there's a fluid inside. And what Pascal's principle says is that if you have a small area and a large area, so the small area is A1, large area is A2. If you apply a small force F1 on the small side, you're going to generate a big force F2 on the other side. And the equation for Pascal's principle is going to be, well, it's actually based on the pressure on the small side is equal to the pressure on this side is equal to the pressure on that side. And the equation comes out to be force 1 over area 1 is equal to force 2 over area 2. So here, in terms of the values given, let's see, the 0.2 is going to be the small area, so this is going to be A1. And let's see here, 12 newtons is applied to the small end, so this is going to be F1. So we're trying to find F2. And the big area is going to be 0.85. Okay. So now we can try to solve for F2. So F2 and I can just plug in. So F1 is going to be 12. Area 1 is going to be 0.2. F2 we're trying to find. And area 2 is 0.85. And cross multiplying, you get F2 is going to be 0.85 multiplied by 12 over 0.2. and that should give you 51 newtons. Okay, and so now the other part says so this is, now we're looking at the large N, so this N here, A2. The fluid is flowing through with a velocity of 0.36, and we want to get the flow rate Q. So then here, the flow rate through the large N is going to be just the large area multiplied by the volume, and that is going to give you, the large area multiplied by the velocity V here. So that's going to be large area 0.85 multiplied by velocity, which is 0.36, and that's going to give you a flow rate of 0.306 cubic meters per second.